Right. Good morning. So talking about logic gates, we have conducted two classes for logic gates. In the first class, I have explained the background of logic gates. I explained what the logic gate is and also the basic block diagram for a logic gate. So we discussed such things in the first one. In the second class, we discussed about one of the most important gates, which included in our syllabus is AND gate, right? So we studied about AND gate. Look, about AND gate, we have to remember three things. I explained all the three things in that particular class. The first one is symbol, right? So this is the symbol for AND gate. Okay, this is the symbol, but here it doesn't have inputs or output, it only symbol, right? But if you want to add the input, you can write the input and output. For example, if the question is to write or draw the symbol of AND gate in an examination paper, you can only draw this one, that's enough. Or even if you want, you can add the inputs, maybe two inputs, maybe AB, and the output, right? A dot B. This is also correct. Okay, but the symbol is here. And also we studied about the logic of AND gate, which means the behavior, the functions of AND gate. So I clearly explained that, right? When only all the inputs have electricity, output also has electricity. When one of the inputs doesn't have electricity, output also doesn't have electricity, right? And in order to understand this logic, we also constructed a simple electric circuit having two switches and a bulb and battery. Okay, so I hope you all understood such things. Okay, right, look. So today we have to take the second gate, which is OR gate. Okay, look here, OR gate. So about OR gate, we should remember these three things again. So we discussed three things about AND gate. Here also we have to discuss the same thing, right? Three things. First one, symbol. OR gate also has a symbol. I have to introduce that one. Second one, there should be a logic. There should be a function for OR gate, but that must be different than AND gate. Okay. And also the third one, to understand the function of the OR gate, we have to build a simple electric circuit. Okay. So starting from the symbol, look here. There is a curve, maybe a small curve and a deep curve, right? Like this. Okay. This is the OR gate. But AND gate, this is straight and you have a curve. This is AND gate. But here in OR gate, you have a curve in front. Right, so this is the symbol. Let's input two, right? So I take two inputs. This is A, this is B. As we discussed earlier, every gate has one output, right? Only one output found. So I have this output here. This is output. Okay, look again. This is the symbol for OR gate. It has two inputs in the name of AB. You know, inputs are nothing. They are wires for carrying the electricity. Here I have only one output. Output also nothing. That's a wire for taking the electricity as the output. Okay, right. So now it's a symbol, right? That's okay. But now we have to understand the behavior of the OR gate, the function, right? Logic of the OR gate, right? Look here. Everyone knows that the logic of a gate should be shown in a truth table, right? I explained about truth table in the previous class. So definitely for showing the logic of the OR gate, we have to construct a truth table. But before constructing or before showing the logic in the truth table, I'm going to show the inputs and the output on the symbol first, right? On this particular circuit. After that, I will put it in the table, right? Watch it carefully. So you have two wires. So as we discussed in the previous class, there should be 4 combinations, 4 different chances that you have. Okay, so look here. So now at the moment, assume both wires, right? Both wires have electricity, right? So assume this wire has, this wire has. So if a wire has electricity, that can be taken as 1. Okay, so here also 1. So what is it? In both wires, electricity is there. Okay. Now electricity is flowing. This is a logic gate, which means this is an electronic circuit, which will perform something, which will do something. As a result of that that function, there will be an output found. You know that sometimes that output is electricity, sometimes not electricity. But here, what happens? There will be electricity. Okay. After showing all the 4 combinations, I can summarize. Okay, watch it carefully. When both inputs have electricity, here output is electricity. Okay, something happens inside. After that, we will get electricity. This is the first instance. I have 2 wires, so I can try differently, right? So now assume wire A has electricity, but wire B doesn't. Okay, so in one of the wires, electricity is there. In another, no electricity. Okay, so now electricity is flowing only through wire A, not wire B. Now also something happens in the circuit. As a result of that, there will be electricity. Okay, you can find the electricity as output. This is my second combination. Third one, I can do differently, right? So how A doesn't have electricity, but B has. Okay, wire A doesn't have electricity, but wire B carries the electricity. Now also this gate will perform something. It has to perform its behavior function, right? As a result of that, you will get the electricity. Okay, we get the output as electricity. Okay, finally, we can stop the electricity in both wires. Okay, no electricity in both wires. Now, as a result of that, there will not any electricity. Okay, so now you can easily compare the inputs and the output, right? Look here, 1 1, here you got 1. 1 0, you got 1. 0 1, here 1. 0 0 0. Can you pick? Can you guess the logic of the OR gate? What's the function?
Sir, if both wire do not have electricity, the output is 0.
Okay.
If only one or both have electricity, the electricity is come as the output.
Okay, so we can simply define that as when one of the inputs is high. Okay, at least when one of the inputs has electricity, output should be electricity. Okay, I repeat it. When one of the input has electricity, output should be electricity. Look here, you got electricity in the first 3 instances. How? In the first 3 instances, one of the inputs is electricity. Look here, in the first instance, both have electricity. Okay, both wires have electricity. Look at the second one. In the second one, wire A has electricity. Look at the third one, wire B has electricity. So if at least a wire has electricity, output should be electricity. So when OR gate produces Z, right? When OR gate produces 0 as output, when all the inputs are zeros, right? Which means when all the inputs do not have electricity, OR gate produces 0 as output, which means no electricity. Clear? This is the idea. So even now you can think about the meaning of AND and OR. In English, you know, if it is AND, it means, things are compulsory, right? Say, I can simply say that you have to, I can give an instruction to you like, you must bring both workbook and textbook to the school, right? Bring both textbook and workbook to school. So here, look at that word and, textbook and workbook. So here I'm trying to tell you that both are must. You cannot bring one, right? Both are must. This is similar to AND gate. Look here, think about our AND gate, right? In AND gate, when both inputs have electricity, output is electricity. So this is similar to this idea, right? So that's the reason why the name AND is given to that circuit. Actually, they are circuits, right? Electronic circuits. But the names are given based on the behavior of them. Look here, this is O. So I can also tell you like, okay, bring your textbook or workbook to your school, to the class. Bring the textbook or workbook to the class. So here, I'm telling you that you have to bring at least one. Yes, you can bring both. That's not an issue, but at least bring one. You cannot be at school without two books. That is not the expected thing, right? So this is exactly same as OR gate. See, one is enough, maybe via A or via B. So when one wire has electricity, output is electricity. This is OR gate. Okay, right. So let's display the function of the OR gate in the truth table. Okay, right. So I'm going to delete these things. I have written these ones and zeros here in order to demonstrate, right? But this is not the right place to write. You have to show them in the truth table. You know what truth table is, right? So truth table is a structure for showing the logic of a particular gate. Okay, let's see. You have two inputs, A, B, and the output. So there can be four combinations. So let me write them: 0, 0, 0, 1, 1, 0, 1, 1. You may write in any order, but this may be followed by many people. So any order is possible, right? All you have to, focus is having those four things. Okay, if you have these four combination, that's okay. Order is not a matter. Okay, so tell me the outputs here. What should I write first?
0.
0. Second one?
1.
1. Next? 1.
1.
1.
1. Okay. 0, triple 1. Because in the first instance, both inputs are zeros, so output 0. In the next three inputs, one of our inputs is 1, so output 1. 1 means electricity, 0 means no electricity. Okay, this is the truth table. Right, look, I have already explained in AND gate that having the word O output is correct, because this is the output of OR gate. But the word output is a common word. Output is there for all the gates, not only for OR gate, right? Even in AND gate also output. So you have to show the exact output of this gate. It is not good to write the word output. Have you understood? So you have to tell the output format of this gate. So don't write like a common word. So do you remember the output that we have written for AND gate? How did we write the AND gate output?
A and B.
Yes, A and B. Because that's AND gate, you have two inputs, A and B. So the output would be A and B. But remember, for AND, we use the dot. I told you that dot is always used because that's too easy to use. It's one small symbol. But if you want to write the word AND, you have to take some time. At the same time, it takes some space. Okay, so we often use dot for AND. Here also, look at that. You have the OR gate. Your two inputs are A, B. So your output will be A, O, B. This is how the output is written. It is exactly same as the way that we used in AND gate. Okay, A, the gate name is in the middle, O, then the next output, A, O, B. Again, even though this is the format, we avoid this method. We mostly follow another method because the reason is here we have a word in between. In between two inputs, we have a word, right? Even though this word has two letters, sometimes it's slightly, difficult because the reason is same. It takes some time because I have to write OR, and also maybe it takes some space, right? So always use a symbol like A plus B. Okay, A plus B. So plus means O gate. So even you can pronounce this as A O B. Okay, you even reading as A plus B also correct, but A O B. So here also we can change this output as A O B, right? A plus B. Right? So this is the gate, symbol of the gate, and this is the truth table. So now put the heading O gate, O, capital OR, put the heading OR. And straight away draw the symbol first. Draw the symbol. Make sure that you draw with pencils. Don't use the pens. Particularly when you are drawing symbol, use the pencils. Maybe truth table can be used, can be constructed with pen, right? But for the symbol, use the pencil because you have to erase sometimes. So pencil is the best option. Write both outputs, A O B, A plus B, both the same. Okay, after drawing the symbol, put the subtitle as truth table and draw the table. Truth table, or even you can write truth table for gate, right? Anything is okay. Truth table or truth table for O gate, and draw the truth table. Finished?
Yes, sir.
Okay, right. So this is O gate. One thing, so the regular attendance is must. Even if you miss a class, you cannot continue because these are this looks like a chain, right? So suppose if you are unable to understand, or suppose if you miss the AND gate, sometime understanding the O gate is difficult because since AND gate is the first gate, I took enough time to explain all the basics, right? So sometimes when you miss the class and when you participate in O gate, you may not understand that properly. You can understand something, but it is not. Oh, I cannot say that you can get the full idea. So better to attend each and every class particularly of this unit. Maybe for some other units, even though you miss a class, you can go through the notes or write some other things and you can understand. But especially this unit is different because it is electronics. For the very first time, you have such experience. So definitely you have to understand everything from the basic. So don't miss any classes. Try attending to every class, right? So I'm taking very small part in each class, right? So you can easily catch them, right? So this is the O gate, but look here. Here also you may have some problems in understanding the logic. Look here. Take one combination. So let me take the third combination. Okay. I take the third combination randomly, right? I just take it. Look here. Input A has electricity. B doesn't have electricity, but output has electricity. There is an output. So A has electricity, B doesn't, but output has electricity. So if somebody asks me to prove that, because in one wire, no electricity. Electricity is found only in first wire, right? Wire A. But even though electricity is found in one wire, there is an output, right? Electricity is there as output. So you may wonder, and you may ask me to prove that, because in AND gate, it wasn't there, right? In AND gate, when one wire has electricity, there wasn't no electricity as output, right? There wasn't electricity as output. But here, even though one wire has electricity, you have output in terms of electricity. So you may have some doubt, right? You may ask to prove that. So now I can say that it is just a symbol. I cannot prove that because it's the behavior of the OR gate. That behavior is reflected in this particular diagram. So this is just a symbol. I cannot prove that, or I cannot justify. But if you understand, if you want to understand the logic of the OR gate, yes, you need a simple electric circuit. With the help of the simple electric circuit, you can understand the logic or the function which can be performed inside of the AND gate or inside of the OR gate, right? So let's construct a simple electric circuit for understanding this logic. Okay, look here. So I just want to draw on the top here. Right, look here. So I hope that you remember the electric circuit which we have drawn in the previous class for AND gate. There we have connected two switches serially, right? Serially, side by side, we connected. Look here how this circuit, looks like. So I take a switch here, and I take another switch. I connect them parallelly, not serially, parallelly. And I have a bulb and a battery. Okay, two switches taken, both are connected parallelly, and a bulb and a battery, right? So let me take this switch as A, this is B, the bulb is Q. Okay, so let's see how this bulb is handled by these two switches. Okay, so let's understand them in a table with the help of a table. So this is switch A. Okay, switch A, switch B, and bulb Q. switch A, switch B, bulb Q. Right, look at the current position. Now both switches are off, right? Switch A, switch B, both are off. So off means 0. Okay, we studied. Both are 0. Now look at this circuit. What about bulb Q? Will it work now?
No, sir, no work.
No, right? No,
No.
because both switches are off. So electricity cannot be carried out, right? Because both are off here. So there is no way to go up to them, right? So maybe beyond them, right? So there is no electricity here. So bulb doesn't work, 0. So now let me off this, okay, on the switch B. Any combination, okay. But now I on switch B. Switch A remains off. So switch A off, 0. Switch B on, 1. What about bulb? Will it work now?
Bulb burns.
Yes, it works, right? It lights, because look here, electricity can be flown here in this direction. It can be completed. There is a complete circuit found, right? You can see that. Look here, this can go here and it can go along this way because the switch is on here. So electricity can be traveled here and the circuit is complete. So now bulb works. This means 1. Okay. Then we can on this B and off the switch A. Sorry, on the switch A and off B. This is on, this is off. So A on, which means 1. Switch B is off, this is 0. What about bulb now?
Bulb burns.
Bulb works.
Yes, now also works. Look here. It goes in this direction and it can be a complete circuit. So bulb works. Again 1. Finally, we can on both switches. So A is already on. Let's on switch B. So this is 1, this is 1. What about bulb
Bulb
Q?
works. Bulb works.
Yes. Now also works. We see electricity has choices, right? It can go along this way or maybe even it can go in this direction. So definitely it works. Okay, right. Now, the behavior of this electric circuit is shown here. Okay, this is how this circuit works. That behavior is reflected here. Now try to compare this table and the truth table that you have written. This is the truth table. This may not be the truth table, right? This is only for understanding this behavior of this electric circuit. But now you can easily understand that both are same. Look here, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1. Exactly same. So now we can simply say that the logic or the function of the OR gate can be like this, right? So maybe, but this is not the OR gate, right? This is not the OR gate, but it looks like the function of the OR gate. Because in OR gate, when one input has electricity, output has electricity. So assume this is one input, one switch is one input, another switch is another input, second input. So now it shows that idea. So we construct this electric circuit only for getting the idea about gates, right? So this is the simple electric circuit for OR gate. So write as a paragraph, right? In the next line, write as a paragraph. In OR gate, OR capital R, capital letters, in OR gate, comma, put a comma, when one of the inputs is high, when one of the inputs is high, HIGH, high. What does it mean? High? High means?
Electricity found.
Yes, electricity is there and electricity is found. So I repeat it, when one of the inputs is high, again a comma, put a comma, electricity is found as output. Electricity is found, FOUND, found as output. As output. As output. Right, full stop and continue. O gate produces, O gate produces low output, LOW, low output. Low output means?
No electricity.
Yes, no electricity, right? I repeat it. O gate produces low output when both, wait 1 second, when, don't use the word both, because in this particular example we have 2 inputs, but there may be 3 inputs, 4 inputs. So it is not good to say that when 2 inputs are 0. It is good to say when all the inputs are 0, right? So when all the inputs do not have electricity, when all the inputs do not have electricity. Okay, right. In the next line, write it in the next line. The following simple electric circuit, shows the logic of the O gate. Again, capital O gate. Okay, now draw that, and also draw this table.
Sir,
Yes.
Sir, your video is not clear, sir.
Why? Is it same for others?
Ipo
Yes, sir.
okay,
No,
sir.
No, sir. No.
Right, do both. Draw this one first and then write the table. This is A, B, here Q. Switch A, switch B, bell Q. Finished? No?
yes, sir. Finish.
Is there anybody who doesn't finish? Okay, I give a minute or two, finish it quickly. Okay, right. So this is about OR gate. So we have taken all the three things about OR gate, started from symbol, then the truth table, finally the simple electric circuit to describe the function. Okay. Right. So let's take our last gate, right? The third basic gate, that may be the last gate, NOT gate. So heading NOT gate, capital NOT, NOT gate. Not gate or not. Put the heading, not. Right. So first of all, we have to take the symbol, right? Every gate has a symbol, unique symbol. So every gate has a different symbol. Okay, look here. So this is the symbol of NOT gate, a small triangle and a small circle here in this part. We often call that as a bubble because it's too small, right? The circle is too small. So since it's too small, it is always known as a bubble. You know, bubble is always small, right? So this is the symbol. And also when we draw circuits, we keep the size of this NOT gate little bit smaller than the other gates. See, after that, after studying these three gates, we will have to connect multiple gates together to build circuits. For example, say you can connect the AND gate, maybe OR gate, NOT gate together to build some circuits. There, keep the size of this NOT gate little bit smaller than the other gates. Maybe you can keep the OR gate and AND gate in same size, right? Little larger, but always keep the NOT gate size maybe smaller, right? That may not be the rule, but do it like do it a little slow. I mean smaller. Okay, right. So about NOT gate, you must remember one important thing. This is slightly different than the other two gates. Look, in other two gates, in AND gate and OR gate, at least two inputs are required. Minimum two inputs. You can input 3 or 4, doesn't matter, but minimum two inputs. But here, minimum or maximum one input, right? You cannot input 2 there. You cannot input 3 there. Only one input, right? That may be the difference here. So let's take a wire. This is input. I take it as A. Here, as we discussed, every gate has only one output. Even NOT gate also has only one output. This is output. Okay. So the symbol of NOT gate with an input and an output. So let's understand the behavior or the logic of the NOT gate. Look, when you have two inputs, you can have 4 different combinations. Think practically. So when someone gives you 2 wires, you can try in 4 different ways. You can pass the electricity in both wires. You can stop the electricity in both wires. You may pass electricity in the first wire and stop the electricity in the second wire. You can stop the electricity in the first wire and supply the electricity in the second wire. So you have 4 combinations. But now assume someone has given only one wire to you and asked you to check the electricity, asked you to provide the electricity or stop the electricity. Now you can have only 2 chances. Am I correct? You have only 2 chances. The one is you can supply the electricity or you can stop the electricity. You can't say that you have 4 combinations here because here you have only one wire. Clear? So here you have only 2 chances. Okay, let's see. Now assume wire A has electricity. A has electricity. This is NOT gate. Definitely NOT gate has a function. I will describe the function a little later. So by keeping that function in my mind, I try to give the output. So here the output, after performing this logic, this will produce 0 as output, which means no electricity. Okay, output is electricity, but the result is not electricity. This is the first one. Yes, you can have one more. So here assume input is 0, which means no electricity is there. Okay, but after that particular function, it produces the electricity. Okay, when input doesn't have electricity, you have electricity as output. Okay, so this is 1. So now you can easily compare the inputs and output. You have only 2 chances, right? Only 2 chances. Look here, one input, here output 0. Here input 0, here output 1. Only 2 chances. Right, look one second. Now, okay, can anybody pick the function of this NOT gate? Now you can easily check the input and output, right?
When electricity is supplied to the NOT gate, it doesn't produce current as output.
Okay, but give me the common idea. What's the behavior of the NOT gate? You have to focus on both inputs. Here input 1, output 0. Here input 0, output 1.
What's the mode?
Any others? It's very simple, right? Compare your input and output.
Say mode. Say
What is it?
opposite, sir.
Yes.
Opposite.
It produces the opposite of the input. Right? Because in a gate, listen to me, in a gate, you have only 2 values, 1, 0. 1 means electricity is there. Electricity is present. 0 means it's absence, right? Electricity is not available. So here, electricity is there, but 0, no electricity. So this is opposite. Here, electricity is there. Sorry, electricity is not there, but you have electricity is here. So it is opposite. So that's why often NOT gate is known as inverter. right? Inverter means it produces the opposite. Zeros become ones, one becomes zeros. That's the meaning of NOT gate, right? So this is the idea, but again, we can't show these ones and zeros here. That may not be the right place. So let's show the functions in a table, truth table, right? Let's draw the truth table. This time our truth table becomes very small because you have only one input and one output. Okay, so let's draw the input, write the input first, A, and the output. Only two columns. And also only two rows, 0, 1. A can be 0 or 1. So when A is 0, you know output would be 1, opposite. When A is 1, output should be 0. This is the truth table, right? It's a very small truth table. Look, one more thing. Check this again. Again, the word output is not the suitable one. The reason has already been given because output is a common word. So you have to specify the output of the NOT gate when input is A, right? So look at the way the outputs of AND gate and OR gate were written. So in AND gate, we used to write A and B. So which means we put the gate name in the middle. So on both sides, you have inputs, A and B. Even if you take the OR gate, the gate name is in the middle and the two inputs are on both sides, right? A or B. But here, when you want to write the output for NOT gate, you cannot keep the gate name in the middle because you have only one input. So how can you keep the gate name in the middle? You can't say A not. Okay, how can you say A not what? You don't have any other input. A not B. B is not there. So here, the way of writing the output is the gate. Now you must realize that the gate name may be in front or maybe gate name is after input. These are the only two choices, because you cannot keep the gate name in the middle. So the right way is not A, right? Keep the gate name first and then write the input. So the output would be not A. Okay, you can't write A not. That is wrong. This is the format, not A. But we often avoid this method and we used to show the gate name by a symbol, right? So this is the symbol A bar, right? A bar. The top line is called bar, B-A-R, bar, right? A bar. Or even you can write this as A dash. This is also possible. A bar or A dash, these are the two common methods, common ways for showing the NOT gate. But of course, this is the standard format, not A. Okay, but A bar or A dash also correct. So here also, it is not the right method, right? Don't use the word output, show the output. So this is A bar. Okay, so this is the NOT gate symbol and the truth table. So now draw the symbol first. Draw the symbol first. Keep this circle in a very small manner, right? Don't, you can see the dimension of this, right? Take a look at my triangle that looks little larger, but circle is very small. You cannot draw like this. This is not the right way. You cannot draw like this. Now see, look at the size of these two. Now looks same, right? This is not the right one. Your circle must be very small. Finished? Yes, right? Okay. Right. So next line, next paragraph. Not gate, capital N-O-T, not gate produces the opposite value, produces the opposite value of inputs, sorry, of input within brackets 0, you can put in number, right? 0 becomes 1, again number, right? 0 becomes 1 and 1 becomes 0. 1 becomes 0. Okay, next line. The logic of the NOR gate, the logic of the NOR gate, sorry, the logic of the NOT gate, sorry, the logic of the NOT gate can be described in the following electric circuit. Okay, so here also you have to understand, because look here, when electricity is not here, you have electricity as output. Here no electricity, but here you have electricity, right? So you may wonder how it's possible, because electricity doesn't have input doesn't have electricity, but output has. So you may wonder how it's possible. So in order to understand such functions or logic, you need to build a simple electric circuit again. After that, you can understand. Okay, so we can do that later, not today, because we don't have enough time. That takes some time. So again, go through the today's lessons, right? Go through the most important part about OR gate, right? The gate symbol, the function, which means truth table, and the circuit, and also the NOT gate, these two. Okay, so after that, after finishing this simple electric circuit, we can start doing some questions. Okay, not today, maybe in the next class. All right, that's it for today. Okay, so go through everything and understand them clearly, so we can meet in another class, right? See you next time. Thank you.